exploring the phenomenon of the heating curve. And the heating curve is true for any substance. And if you played with this, there were three different substances. And while each one has the same pattern for the heating curve, the result or the temperature at which these things happen is not the same. So here you can see heat is applied to a solid and that solid melts. And while it's melting, the temperature is not changing. So you'll see here the temperature does not change while it's melting until it's all a liquid. Then the temperature can change until it gets to the point where it's boiling. And then when it's boiling, again, the temperature does not change. So adding heat is called a heating curve. For this one, the span was 0 and 100. For the next one, which is the purple rock, you can see it actually heats the solid up a little bit. So here's where the solid's heating up, and then the flat part is where it's melting, and then after it's all melted is when the temperature starts changing again. And then when it's boiling, it flattens out again. So this is sort of the phenomenon we're trying to explain here. And because of that, um, in every case, the heating curve will have the flat parts that are the change of state. So in this case, we have melting if you're headed, if heat is added, and freezing if heat is removed. So let me actually put those colors so that one is red. Right. So here heat is added, here heat is added, and then heat is removed with freezing, and heat is removed with condensing. And the starting spot would be a solid. So everything here would be a solid in this chemical, which is water, up until 0 degrees. And at 0 degrees is where the melting or freezing would occur. Above 0 degrees is where you encounter a liquid. So this is a liquid. And then that changes temperature until you reach its boiling point being this 100 degrees. And then if you add heat at the boiling point, it'll all stay as it's at that temperature until it gets into a gas above 100 degrees. So the solid phase starts every heating curve. The melting or freezing would occur depending on which direction you're at that first plateau. Then the liquid phase would be what you're looking at in this heating curve, and then it would plateau again at the boiling point. So we were given this list, and this list is supposed to guide you through understanding a couple things. One, that everything doesn't just melt at 0 and boil at 100. Some things melt at minus 114. Some things melt at 146, right? It depends on the substance and what this chart will help tell you. And then the other thing, so if we were to look at, say, hexane, all right, so let's take a look at hexane here. So hexane has a melting point. That first point would be at negative 95, and then that second point would be at 69. So if we go here and do this for hexane, so that melting point, that first plateau is negative 95. So this first plateau here would be negative 95. And then that second plateau would be at 69. Second plateau happens at 69. So if I asked you, for example, what state is hexane? So what state is hexane at 50 degrees Celsius? 50 degrees Celsius is going to be between 90 and 90, negative 95 and 69, right? Somewhere about halfway would be a 0 point, and then the rest of the way would be up to 69. So 50 would be pretty close here, right? Somewhere around here would be 50. And in that 50 region, because we hadn't reached the boiling point yet, that would be the liquid region, right? So this is all the liquid region. So we would say that it is a liquid at 50 degrees. If the same question is asked, only in this case we asked what is hexane at um, minus 104 degrees Celsius. Minus 104 degrees Celsius is actually going to be a little bit lower than minus 95, right? Minus 104, it will be down there. That's going to fall into that solid region of this graph. So in that case, hexane would be a solid. And if we ask for anything above 69, let's say, what is hexane at uh, 96 degrees Celsius? So 96 would be above 69. It would be up here. And that's going to fall into, let me just put that as 96 before I do this. And then that's going to fall into that gas area of our graph. So the point here is for any one of these things, the lower number represents the border between when something will change from a solid. So it'll be a solid below these numbers, and it'll be a liquid above those numbers. And then this boiling point is that border between when something's a liquid and when something turns into a gas. So you will just use these numbers as a guide. So let's get into, let's say, sucrose. So what state, what phase is sucrose at 120 degrees Celsius? So sucrose is right here. It melts at 86. It decomposes higher than that. So we can say it is either a liquid or, and I'm going to try to avoid these ones actually, but we could say that's a liquid. It wouldn't be a gas because it doesn't become a gas. So it's either a liquid or decomposed. But that's why I won't ask that on a test or anything. That was just to explore that because it was above the given 86, because the number we looked at higher than 86, it was in the liquid. All right. So this is the same list, same, or not same list, but a similar list. The liquid happens in between the melting and the boiling points. It would be a liquid. It would be a solid if it were below any of those things. And then it would be a gas if it was above any of those things. So if we were looking at hydrogen sulfide, so if the question was what state is hydrogen sulfide at, now I saw it was like, so let's say negative 50 degrees Celsius. So negative 50. Negative 50 for hydrogen sulfide is still above negative 61. So let's take a look here. So negative 61 would be for hydrogen sulfide. The boiling point, negative 85, would be the melting point. This is for hydrogen sulfide. So if we're talking about negative 50 is closer to 0, so it would be up here, right? Because we're headed toward positive. Down here, we're getting more negative. So negative 50 would be above 61. That's in the gas region. So we would say that because of that, it's a gas. We could also do it by looking at what we have here for hydrogen sulfide. 61, negative 50 would be higher than that number, so it's in the gas region. If we said negative 70 for hydrogen sulfide would fall in here between negative 85 and negative 61. So that would fall in here, which would fall into that liquid area.